Alright guys, so here's some extra notes for your similar polygons. And the biggest thing, guys, is you've got to set things up with shapes that are equal in size or shapes that match with each other. So you always got to look for what matches. So that's kind of the key, is what's going to match. So what do I really mean by that? I mean, like in this triangle, you have a triangle here. All right, and then you also have a larger triangle, all right, there. And so sometimes you have some things that can match with the small shape and the larger shape. Now, for these types of examples, if I'm trying to set something up, a proportion to help me with this, all right, I could say 3 matches with x because it's in the smaller triangle, and then that's equal to, since I started over here with the 3, I got to start over here with the 5 as well. 5 matches with 2.5. Okay, and then I can solve this. I can go to work cross multiplying, all right, and solving this proportion. So 5 times x is 5x. 3 times 2.5. All right, what is that? 3 times 2.5. You get 7.5. And so we take 7.5 divided by 5, and we get that x is equal to 1.5. Okay, now let's look at this example. Okay, and what they do in this one is they don't necessarily give us these 2 little pieces like they did earlier. This time they gave us the whole piece on the bottom. So what I've got to do is I've got to make sure that I know everything matches. Okay, so this 9 is kind of irrelevant in this situation because there is nothing in that spot that I can match with. All right, so what can I do? What information do I have that could also help me? Well, this whole 21 right here, all right, I know that whole 21 can match with whatever this whole is here. All right, and that whole happens to be 9 plus 6. So 9 plus 6 is that whole thing. All right, and that happens to be 15. So that's some extra information that I'm going to have to add into this problem. All right, so I can start out by saying 21 over 15 because I just found that from my common sense when I added those together. And then that's equal to, since I started with 21, I need to start with x in the bottom right here. All right, so x in the top of that fraction over 6. Okay, and then we're going to cross multiply just like we always do here. 15x equals 21 times 6. So 21 times 6 is 126. And we divide by 15. We get that x is equal to 8.4. Okay, so kind of the same idea of matching things together, maybe getting the whole or just the part. All right, that's going to help me as I go through these problems. Okay, so let's look at this type of problem. So I have a large triangle that is bisected, and so these 2 angles here are equal to each other. And I'm trying to find some of these missing side lengths in the triangle. Okay, so the first thing that I've got is this triangle over here. So what matches in this triangle? Well, obviously we've got 12 over 3. Okay, so we can set this up, 12 over 3. Since I started on the top over here, I need to start with the x over the 5. So x over 5. Okay, and that way everything matches up. Everything is kind of in its correct spot, its correct location that we need it to be in. So 3 times x is 3x. 12 times 5 is 60. Again, we divide by 3 to finish this thing out. All right, 60 divided by 3 is 20. Okay, and so I can go in and know that that's right. All right, I'll also notice that, hey, 3 times 4 is 12, and 5 times 4 is also 20. So that's an extra way that I've got to check this problem out and make sure that it makes sense. Okay, the last type of problem we're going to look at is something that's not exactly triangles. It's a bunch of different parallel lines together. But you're going to use the same process to set these problems up. So let's say that we have 3 lines here, 3 parallel lines, so they're never intersecting, okay? And let's say those lines are cut by 2 non-parallel lines, okay? And so they make a whole bunch of different spaces in our problem. All right, and let's say that the length from here to here is 9. The length from here to here is 7. All right, this length is unknown. And this length right here is, let's say, 10. Okay, so we've got to find a way to set this problem up, all right, and go to work. Well, obviously, just like you're thinking, these 2 things will match together as well as these 2 things. So I'm going to say 9 over x is equal to 7 over 10. All right, so we can go and solve this problem just like always. 7 times x is 7x. 9 times 10 is 90. All right, let's divide 90 by 7. Okay, 90 divided by 7 is 12.85, so about 12.9. All right, and so that would work for this problem. Okay, last thing. So let's look at some useful kind of word problem deals. All right, question 5. Let's say that we have a person here. Let's say this person is 6 feet tall. All right, pretty tall guy right there, or girl. And let's say that their shadow happens to be 10 feet. Okay, let's also say that there's a building, all right, on the other side of town. Okay, and our building is 100 feet tall. Okay, how long would the building shadow have to be? Okay, so again, these are kind of like our similar triangles. All right, you could make this into a triangle if you wanted to. All right, but you really don't need to do that. Let's look. Okay, obviously the 100 matches with the 6 because those are both the height of the person in the building. So we could say 100 over 6. All right, we're going that direction. So in our next fraction, we need to go the same direction. I need to start with x and go over 10. So x over 10. So here we would say 6x equals 1,000. All right, and when we divide 1,000 by 6, so if we take 1,000 first divided by 6, all right, you get 166.67, or 6 repeating, so 667, whatever, okay? So that would be the length of that shadow. Okay, so proportionality, all right, similar triangles. It's all about setting up what matches to each other.